This video is kindly sponsored by Project Red. Check the link in the description to find out more. This video is made possible by 3D Musketeers, offering full-service product development, prototyping, and production, helping you make awesome from art to part. Links in the description. Hello everyone, welcome to this week's Meet a Maker. We are joined once again by beautiful co-host Faye. Hello Faye.
Good morning everyone.
And this week I'm really excited because we are meeting Andrew Singh. Hello.
Hello! How is everybody?
So good. I've been stalking you on Twitter for months, so I am so excited that we are getting to do this and hang out. It's so awesome.
I absolutely could not be happier.
Yeah, the feeling is totally mutual. Like, you two make such awesome projects. This is definitely going to be just, like, I think it's going to be a lot of gushing in general in both directions. Like, you do so much cool stuff, and I love it. I love this series, too. I love the idea of talking to people from, like, just every possible niche of making.
Yeah, it's been
Andrew,
so
you're
cool.
the menchiest. You're the menchiest mensch.
The menchiest. Mid-mouthful, you're so mean.
Like, it's so funny that you say that. I just did, this is my second ever, like, podcast type situation, and the first one I did was my friend Jeremy, and his podcast is called Point of Jew. And when I went on it, my first thought was like, I'll bet everybody is going to think that this is like a Jewish podcast. And like, I wonder if this is going to be something where like people are going to ask me if I'm Jewish, and I have no like good answer other than no.
So wait, then what was it about if it wasn't a Jewish podcast?
It's just Jeremy. He just talks to people. Like, it's like he's Jewish, and that's his.
Okay.
I think
understand.
he's Jewish.
Okay.
He's never actually explicitly said it. Now I'm wondering.
If he's not,
all right,
it's a little
we're
weird.
off on such a tangent.
That's okay. This is how it goes.
You've seen it. Clearly, we're a tangenty bunch. But do tell us.
You are menschy. You're very menschy. So
very, very awesome. All of your projects, I love them. So yeah. Should we get crack-a-lackin' those? Start. How about you tell us?
Absolutely. Yeah. Yes. This is the time. This is the Andrew time. This is the Andrew show today. So please tell us a little bit about yourself. Like, what are you known for? What do you make? Who are you? Who is Andrew Singh?
Such a big question. But I am a person who just really enjoys building things, and I really enjoy helping other people build things too. And that is like my favorite thing in the world is writing something and putting it online, and then like 6 years later, somebody messaging me with a picture of a thing they made based off a thing I wrote. That is the thing I exist for. And I love just making stuff. And so the thing I'm the most known for, I think this is kind of a tricky one because I've done like a couple of projects that like took off online, but I think the biggest one,
yes,
yeah, exactly. I think we've all sort of like done a bunch. But the thing that got me the most like notoriety, where like people I knew from like high school and stuff were calling me, was I built a robot that would automatically swipe right on Tinder, and it was like, and it was one of those. It was just one of those things where like I made it and I forgot about it and I put it online and I was like, oh, this is funny, whatever. And then it just like the next day it just took off like a rocket, and I was like not prepared. There's a reporter from the Wall Street Journal sent me a message on Twitter and was like, hey, can we interview you for a piece we're doing?
Wow.
And I was not prepared for. I was like, yeah, okay,
sure, why not?
So that the thing, it definitely took off. But it's not the thing I want to be the most known for.
What do you want to be most known for?
I think like a lot of the stuff I've made. The thing I printed out. There's this really awesome maker, Print That Thing, Jason Wall, who makes all kinds of really cool stuff, and he does. For the past like year or so, he's been really diving deep into teaching people how to use Blender. And he's made some awesome tutorials. He has all kinds of awesome coursework and stuff. But he made a suit of cat armor that was fully 3D printed for his cat.
I've seen, yes.
And I printed it out and put it on my cat and took a picture of it. And it was another one of those things where it just immediately took off. And like
cat.
The proudest. Oh, it was like the cutest. Yeah, it was like, it worked out. It was such a cute picture. And like, I love the cat. Her name's Virginia. But
Virginia's the best.
I was so excited because the picture wound up being put in a print issue of Vogue magazine in an article about 3D printed fashion.
No way! That's awesome. Heck yeah.
That is
Yeah,
incredible.
and so that's like the thing I tell. That's my like icebreaker is like my cat was in vogue.
That is amazing. Wow. Did they seek your permission before doing that, or did you? Yeah, cool. That's awesome.
Yeah, the woman.
Wow.
Thank
the woman who wrote
goodness.
the article sent me a message and was like, "Hey, can we put this in there?" I said, "Yeah," and I made sure they gave the cat armor was designed by Print That Thing, and I put a little picture in there, and it's one of those things where I just every time I look at it, I'm like, "Oh, Virginia."
That's so cool. Wow, that's awesome.
That is the loveliest. That's just so pure. It is so pure and lovely. I love everything about it. It's just. But you've got other cool stuff too. I know because I can see some stuff behind you as well.
Yeah, some of it's actually kind of floating around. I'm very much a somebody who just enjoys everything, right? Like it's very hard for me if you like ask me what is the thing I enjoy making the most. It's really hard for me to come up with one solid answer. 3D printing is sort of the glue that binds it all together. But I really like making stuff, and so like I've got a couple of things that like I actually got ready just for this podcast to kind of talk about and show, and like just some examples of like stuff that winds up the sort of the byproduct of making. Like you wind up with all kinds of shelves full of wacky stuff. But I sort of got into making when I was first in college. My first run of college, I was studying music theory, and I was really, really very intent on being a concert double bassist. That was like my thing. I played upright bass, and I was really interested in music theory. And
this is so cool.
Yeah, and I really enjoyed it. It was a lot of fun, and but it was one of those things where there was no real clear career path. It was just very hard. And partway through college, I had the opportunity. I was in a band, and we went on tour for a very short period. We kind of went across the country and back. And I was like, oh, I'm in school studying this, but like I could just do this. Like this is something where life experience is very relevant to any job that I would get. And so I wound up switching. I dropped out of college, started playing music, and then discovered playing music is fun. But what was really fun was building amplifiers and guitar pedals and instruments. And so I was like, oh, this is way more fun. Is like I built instruments for everybody, and I was making theremins and like little pedals and stuff, and just giving them to everybody because I was like, this is what I want to do. I like building stuff. And then all of a sudden, I decided to I was like, I should probably check back in on this whole college thing. And I discovered it turns out there's this whole field called engineering where you build things.
Yes, that is a whole field where you build. Yes,
I've heard it.
Something I had just never thought about or considered. And so, the first class I took was an intro to circuits class. And I'm like, oh, so you can design this? You don't just have to like blow up 1,000 pieces in trial and error until something works? Like you can think about it first? So,
that's
and
awesome.
so that got me really interested. Yeah, it was a total light bulb moment. And my college happened to have a 3D printer in the engineering lab. We had a old a Stratasys U-print that was broken, and the tips were clogged on it, and the lab instructor basically said, if you can fix it and get it working, you can use it. And so I was like, all right, well, I've heard about this whole 3D printing thing. This is like 2011, 2012. Like, I've heard about this thing, but I kind of want to try it out, see what it's all about. And so I used it. I printed a couple things, and it was like instantly, I got it. I'm like, this is an absolute everything machine. This is amazing. This is exactly the kind of thing that I want to do. Like, I want to do this for the rest of my life. This is so cool. And so, flash forward to today. That's pretty much still what's going on.
That is awesome. That is, I feel like I had the same moment with 3D printing too. Like you're just like, oh my god, this is amazing. Yes, I definitely.
This is actual sci-fi magic.
Yeah.
Like, yeah.
And it's totally like seeing something on a screen and being able to like click, drag it, and then pull it out of a printer.
And have a physical thing to hold that you made. Yeah.
Crazy.
Yeah. And so I've been really interested in 3D printing. I've basically played around with just about as many aspects of it as I could, from the software side, from the hardware side, from the scanning side. I love 3D scanning. talk about 3D scanning all day. And it's just such an interesting technology because it's sort of like saying it's like somebody saying I like writing or I like reading. Those are both very open-ended things. Like, what do you like reading? Oh, crossword puzzles. You have no idea what's on the other side of that door. And with 3D printing, it's kind of the same thing. It's like, what do you make? Oh, like SJ, I make wind turbines, or I make energy, reclamation devices. And somebody else is like, oh, I make, a jig so I can, cut a chair at an even angle. Like, it's just kind of everything to everybody.
Yeah, it's like glue, like you said. Yeah, for sure.
Yeah, and it's very much 3D printers are tools. At the end of the day, a 3D printer is very similar to like a screwdriver.
I was literally just going to say that. You took the words out of my mouth. Good God.
Because it's like, it makes sense. Yeah, no, we're totally locked in on it because a 3D printer is like, it's a cool device, but like at the end of the day, what's really, you get out of it what you put into it, right? So like if you spend like Billy's tutorial on the SVG tool pathing on the bottom layer, that's not something you do in like 5 minutes. Like that was like, you put work into that and you had a really like clear idea of what you wanted it to look like. And it looks awesome, but it's because you had that sort of that approach to I want to find a way to do this. I want to find a way to like customize these tool paths, right? And that ingenuity can be pulled to all fields. And so that's where it really comes in handy. But
it's a super powerful tool.
It is, and it's so useful, and it's so useful to so many people, and it's hard to talk about 3D printing without like a bunch of platitudes like, oh, it's the glue, right? Like it's such a it's just such a useful thing. So to keep me from like rambling about how great 3D printing is just generally, I've got some like specific things that I'm really excited about. One of the things in 3D printing that I'm really excited about is the process of segmentation, which is taking a 3D scan of a body, whether it's a CT or MRI scan, and then reconstituting that into a 3D model and then printing it out. So here I have, this is my friend John. And
hi, John.
John had a scan done of his spine and sent me the data.
The DICOM data.
The file type is called DICOM, and essentially it's exactly what you would imagine when you get a 3D scan done. It's a bunch of little layers. So you can take those layers and then restack them back up and go in the opposite direction, and you wind up with this. And so it's one of these things where, okay, so what's the use? So you can scan somebody and you can print it. So what is that used for? So here
a lot
in
of things.
Charlotte, oh my God, so many things. But like here in Charlotte, there's a hospital that actually has a 3D printer, and they use a Stratasys machine called a Polyjet that prints out little droplets of liquid resin, and they're different colors and different materials, so you can have rigid and firm and red and white and all sorts of things. And they have it in a cardiac ward where children who are born with heart defects, they're able to scan, print the heart, do a pre-surgical planning procedure where they essentially remove a tumor or close a valve or go through and do whatever it is doctors do to hearts. But they're able to do a couple of mock runs before they actually do this in the pediatric ward. So it's
That's
like
huge.
it's this it's this amazing sort of, the amount of lives that can be saved, the amount of people that can be impacted because the doctor has been able to practice the procedure historically is something that really, it's hard to take a medical model and do one of these prep cases on because they're so generic. But now you're literally working on the heart of the child,
specific
who has the
patient.
problem.
Yeah, that's incredible.
Yeah,
that's awesome.
And that's probably just one example of so many ways that this could be used. Like, as soon as you said it, I was just kind of like, that's it. That's the thing. Like, that is the thing. Because bodies are so massively different. A generic model of literally any part of the body is going to be like maybe of middling use at best, because it's probably not actually anything like what the actual patient is like. So this gives you the ability to, scan the patient, use their specific geometry, so to speak,
There's a place
and go from there.
there's a place here in Brisbane that also does medical stuff, and they work on cancer patients, and they make full, like cast bits of the body because if you can be really specific about where you put the radiation when you're treating cancer, it means that you're not damaging good tissue and stuff, and it's just better overall. You can be really specific and targeted. And they actually print shields that are the exact shape of the cancer from that direction, and they print the part of the body
That's
so
incredible.
the shield fits on that part of the body all perfectly, and it's all just perfect. Yeah, like perfect. And yeah, so it's like really, yeah, I was just thinking, and that's only, these are two things. I know another one who scanned an ear, and like they made a prosthetic ear for this kid, and like, there's just like so many it's so cool. Like the medical 3D printing is wild.
Yeah,
I love it.
Patient-specific stuff that's the big one. And so I got into it. I made the spine fairly recently. I think I made it in February. But I got into it because back in 2016, I had a brain scan done. I had an MRI, and it was kind of a scary time. And I wasn't sure. There was a little bit of a worry that there was something that they were looking for. And so it was a very kind of troubling experience. Everything's fine. That's the good news.
Good.
But it was this really kind of like scary experience, and I kind of wanted to take back a little bit of control. And so they gave me a copy of the CD that had the scan on it, and they said, here's the scan data.
Here's your
like,
brain.
well, what am I, yeah, and it's like, well, what do I do with the scan data? So I kind of looked through it, and as I'm looking through it, of course, it means nothing to me because I'm not a medical expert. I'm not even a medical beginner. I have trouble with Band-Aids. So like I'm looking through a brain scan, like, okay, and then it hits me like, oh, this is a bunch of slices. I'll bet I could turn this into a 3D model. And so I spent a little bit of time on the segmentation, which is where you go through and you remove material based on density. So like your bone, your skull is a different density than your brain. So in the program, you can target those specific areas to remove them. Because if you want to print a brain, you don't also want to print an eyeball. You just kind of want to localize it.
Or a skull.
So, or a skull, or you can go the opposite direction. Yeah, you can just do the bones and remove all the soft tissue. So I wound up 3D printing it, and so kind of like for me to feel a little bit more agency over what was going on, I wound up 3D printing a copy of my brain. And so I have sitting on my desk at my office a full-size replica, and it's like bright pink too. It's so pink.
Perfect.
Brain.
That is so cool.
That's perfect.
I love that that's the way you took agency back to, is that you turned it into this sort of creative process. Like, I think that's such a beautiful thing to do in a moment like that. Like, yeah, that's awesome. Oh, I love it.
Admittedly, I've always been quite curious about that process of taking the scans and turning it into something else. Ever since Simone Yertz did a similar thing with her brain scan, where she basically turned it into a thing. Took her brain scan and turned it into an art. She actually turned it into a paper shredder, which I think is fantastic.
I will be watching that.
Yeah, no, that's a great video. But like, it is that you're taking the slices and combining it into a 3-dimensional thing. What software have you been using to kind of do that?
There's the software called Materialize Mimics that is designed to be sort of professional grade software, where it's got all kinds of detailed processes of segmentation. So you can target specific types of tissue, you can target specific areas. It outputs a file. It's very accurate to the size of the patient geometry, which is the terminology, amazingly enough. But
I love it.
It's something that, that's something that's in use in hospitals. If you're looking for something to use at home, there are a couple open source versions. And so one of them is called Invasalius, and that's the one that I like the most, not because it's the most powerful or robust, but because it's the easiest to use. And if you've ever had a scan done, so broken bone, spleen feels weird, so you sit in the machine, like anything like that, you have some DICOM data on file sitting in a closet somewhere. And you can call your doctor and say, hey, can I get a copy of those scans? And they're going to, be like, why?
You're like, so I can 3D print them? And
so I can 3D print it.
And they'll be like,
but you
really?
can get your hands on them.
Yeah.
And you can totally print it out, and then you can make your own copy of whatever it is. So this originally started as like a stomach situation that turned into, I got the file and I was like, oh, I got to print the spine, because it was like basically from neck to waist. And so with Invasalius, you can just select whatever the target geometry is and then go from there.
That is so cool.
That's amazing.
That's awesome. I am getting an ultrasound soon, so I don't know that that's that you probably need more regular. You need like an MRI or something, right?
Yeah, it's funny you mentioned
Mm.
that. That's a really common question is, can I 3D print an ultrasound? And the answer is like kind of not really.
Yeah, I kind of figured
because
that.
it's really old.
Unless it's one of those
Yeah,
baby,
it's a
the
little bit
3D
harder.
baby ones. Yeah.
Yeah, it's a
Yeah.
little bit harder. Yeah, so the 3D, like the wandy situation, which again, the medical terminology, I'm sure that's a word for that.
1D situation. We all know what we're
wand
talking
thing.
about. Yeah. The baby one.
That one I think you can scan because it's creating like a topographical map. So you have sort of like these like distances that you can then sort of stack back up. But a traditional ultrasound, it's basically like, it's like one layer. It's like a slice.
Yeah.
And so unless you have a friend who's an artist who can sort of draw the slice, actually, now that I'm thinking about it, I'm sure you could use a Blender bitmap program. So just create like a blank image and then use bitmap height. So like the lighter it is, the higher it is, the darker it is,
Displacement.
the lower.
Yeah, you can do it even in
displacement.
Cura.
Thank you. That's the word.
You can just drop
you can make a
JPEG
bump
into
map
Cura
displacement.
like that.
So okay, so you can, but it's going to be disappointing.
Yeah, it's not going to look like, well, it's my boob, I have to get scanned. It's not going to look like my boob. It's going to look very strange. Yeah.
No, it'd have to be quite
as
high
fun.
resolution as well to actually get something interesting with a displacement map. So yeah. Andrew's right. It would probably be a little sad.
Part of me is like, I wish I
oh.
could get an MRI, but then a part of me is like, I'd have to be in a pretty scary situation to need an MRI. So
MRIs
Yeah.
are fun.
So,
They are not
No,
fun.
it's definitely not the kind of thing where you would you do it voluntarily. It's but it's nice that you can do, and a big part of medical 3D printing too is what they call patient communication, which is becoming more common now because of 3D printing, and it's basically what I did except to be provided by the doctor. So the doctor would say, they'd walk into the room, with your brain and say, here's your brain, here's the area that we're worried about, here's the part here's what we're going to do to fix it, et cetera, et cetera. So they're sort of better communicating with you as opposed to using medical terminology, which you might not be familiar with, and explaining in an abstract what's going to be happening. So instead, they're very focused. So it really helps with the process, especially for, again, if you're getting an MRI done or a CT scan done, it's probably not because you're feeling great.
Yeah. Oh, that's really cool. Like,
not all
very much
doctors
more
are good at the
human-centered.
communication either.
Yeah.
Yeah, it's a helpful part of the process.
Yeah. Wow. I didn't even think of that.
That is very cool. I am just laughing a little bit at like I not that it's a tangent, but I'm just like, I'm a little bit sitting here. I'm like, how did we get here again?
Yeah, and so like this is, and again back to 3D printing being like the sort of the everything machine. What really got me interested in 3D scanning, which is tied into medical printing and kind of going on from there. One of my all-time absolute favorite books is called Timeline by Michael Crichton, and it's a book about a bunch of archaeologists who essentially go back to France in the Dark Ages. And it is this amazing science fiction history sort of adventure. They made a horrible movie with Gerard Butler and Paul Walker in 2010 or something like that. It's awful.
Oh,
if you look it up, just pretend it doesn't exist. But the book is amazing because Michael Crichton talks about 3D printing in a way that hadn't been used yet, and he sort of accurately predicts a lot of aspects of 3D printing. And so in the machine, the way that people go back in time is they basically step into a chamber, and very Star Trek style, they're scanned and then they're printed somewhere else. So kind of like the transporter or the replicator. It's like that's been around for a while. But what Michael Crichton talked about was this idea of the transcription error, which is a photocopy, like a Xerox, is always going to look worse on the other side than it does in the original. So if I scan myself and then go somewhere else, there's a chance the Andrew that shows up is going to have one nostril shut or going to have an eye that's offset, And so the book kind of talks about this idea that the more you scan and print something, the worse it gets. And he calls them transcription errors. And I was so interested in that. Like when reading the book, when I first read it, I was like, oh, it's a cool idea. And then flash forward to 2015 or something like that, I had access to a 3D printer and a 3D scanner. And I was like, all right, here's what I'm going to do.
We're doing it.
And so I took a 3D scan of my face and printed out like a little bust and then put it in the scanner and then scanned it and printed, scan, print, and went 5 or 6 generations. And if
See how
anybody
bad
wants
it
to
got.
see the results
seen
of that,
this, yes.
that has been the background of
Potato
my
Andrew.
Twitter for like ever. Yeah.
It's wonderful.
And-
yeah, I love
and
it.
it
That
was
is very,
such-
very funny.
And it's one of those like, science fiction, like it was like existed as like a concept, and now it's not only is it possible, it's like totally trivial. Like you can just do that. You can knock that out in an afternoon.
That is so awesome. I love that project. I think it's just absolutely. It's funny seeing people's reactions to it though, because some people are like, "Why would you even do this?" And I'm like, "It's amazing. Are you kidding me?
Is it
Like, it's so
interesting?
cool. Yeah, and it's just
Yeah.
really fascinating to do a scan of a scan of a scan. Like, I think that's people are funny.
It also makes me think of there's an episode of the TV show Gravity Falls that I feel like ever so slightly plays on that within the context of a complete fantasy nonsense cartoon show, but like it involves
like the repetition.
Oh well, but also the effectively photocopying a person to create another copy, and what happens when that goes wrong, because there's an episode of Gravity Falls in which Dipper finds basically a magic photocopier, and he's able to photocopy clones of himself, but like there's a photocopy error for one of them, and so the Dipper that comes out is really messed up. And he spends the rest of the episode trying to communicate with people, but he can't because there was a photocopy error and he can't speak correctly. And it's just like, yeah, no, he's called Paper Jam Dipper.
Oh no.
It's a whole thing, but you made me think of it. I was like, yeah, no, that is what happens. But that's obviously Michael Crichton's version is a little bit more serious and precise, and Paul's version is considerably sillier.
His version's pretty slapstick too, though. I mean, like the way you find out about it is a guy pretty much like lands, and then immediately keels over from a heart attack, and you're like, okay, like in the book, like what's going on with this? And then they go to the hospital and they scan his heart, and they're like, none of the veins are like lined up. Like his heart is like a whole inch over to the side. So like it's a little slapstick in the context of like this very serious like guy transports and then all of a sudden just keels over and you're like, what?
What just happened here?
There's all sorts of interesting ethical concerns then. Like if you know that that's a risk, is it even ethical to scan someone because they'd be suffering? Like wow.
They'd have to consent.
That's exactly. And so the book tackles that, and so like it's a totally,
it's
book, like
clearly.
You do need to read. It's such a good. I recommend it to like everybody. It's a great book, but it tackles that idea of like, okay, after a couple jumps, like, is it ethical to do it, or to prevent somebody else from doing it, or is this like a determinism thing where like I can't stop somebody from smoking 100 packs of cigarettes in a day, even if it's like that might not be the best thing in the world to do, like back to back.
Interesting.
So,
there's a slight prestige element too.
Yeah,
it's a little prestigey. This much.
Oh, The Prestige, like the movie. Yes.
Yeah.
Yes.
Again, different, but
different,
similar, similar ethical questions.
Variations on a theme for sure.
Yeah. Oh, that's so cool. Is the author still alive? Like, you tagged him on Twitter and been like,
Is who? Oh,
I
Michael
think
Crichton.
he is.
No, he's he passed away.
Oh, what a shame.
Yeah, a couple years ago, I think.
Oh, would have been cool to show him that.
I could be wrong about this though. And I'm going to feel terrible if he's still alive. I'm pretty sure he died.
We'll check just in case.
We'll check. We'll fact check this
Faye's
later.
got the phone
we'll
out.
do like a myth busted
just
thing.
Gonna check this really quick because it's with a C, isn't it?
Yeah.
Crichton.
CHRIGHTON, I think.
He died in 2008.
Oh,
so
2008,
he's been gone for a little while now.
Yeah.
All
So,
right.
and he also wrote
but
Jurassic
still
Park
inspiring
and
people.
like.
Yes, he did.
Cool. Okay.
Yeah.
Because there's 3D
So we're
printing
talking about
in
Michael
Jurassic
Crichton.
Graphs. There's 3D printing in Jurassic Park as well. Like he must have been interested in 3D printing.
So he was actually an ER doctor. He worked. He studied at. I think he went to Harvard. And he was a. He spent time as an ER doctor. He's one of those guys. He's like. If you're reading his Wikipedia, you're like, it's easier just to say the things he wasn't, like just going through it. He's also like 6'7" or something. All right, like I'm turning into like a Michael.
Sorry, what else
Wikipedia
do you have on your
here.
desk to show us?
All right. So we talked about Polyjet, which is this like color printing style, and so I think I got
so cool.
two things that I think are kind of interesting.
I don't know why Polyjet isn't
them-
more common in home style printers because it doesn't seem that tricky to execute. Like I'm kind of just like.
All right, so this ties into like a couple. I've got like a couple of tangents like loaded in the chamber
I love a good
here,
rant.
and so we'll do one of them right now, which is Polyjet, and that question of home printing. And this is like this is this conversation could go on forever, so I'll do my best to kind of constrain it. But like,
We need to put a timer up, like verse.
I know there needs to be like a countdown, or like a guy in the back.
No, I love a good tangent.
It's it's like a stand-up comedy club. There's a guy in the back like flashing a light. Yeah. So okay, so everything I'm about to say, kind of the thesis statement to the crux is just because you can doesn't mean you should, and so that kind of ties into this Polyjet technology. So Polyjet is effectively a resin-based technology, but it's a type of printing called resin jetting, where what you're doing is you have a print head that's moving from side to side, and it's jetting droplets of resin, just like a Sunday comic. And so just like a Sunday comic, you can make different colors by blending 2 or 3 or 4 or 5 or a couple to make 500,000. You know, by
is it Cmyk?
The Cmyk
plus white, I think, or clear. They
absolutely. So for anybody Faye, do you want to actually do Cmyk real fast? Do you want to explain? Some people might not know what that is.
Absolutely. I can totally explain Cmyk. Generally speaking, when it comes to computer screens, there's 2 types of main colors that we use. One of which is RGB, which you might be familiar with as red, green, blue. And that is additive color. That is what you see on your computer screen because light is passing through it. But what happens when you want to create something for print? Because obviously print is not on your computer screen. It's on a piece of paper. You would then use Cmyk, which stands for cyan, magenta, yellow, and black. And that actually translates then that RGB data into something that a printer can understand, but also subtractive color, which is color which light is not passing through. So that is what Cmyk is. So if it's something that is being printed, you need Cmyk instead of RGB.
Wonderful.
Wow, I really pulled that out.
That was awesome.
Yeah. Well done.
Anybody who's watching is going to be like, "Oh, so that's the part they rehearsed."
Nope.
That was not rehearsed, by the way. She totally just
said
that.
She
just a huge color nerd. I just love. I aced all of my color theory classes in university.
Yeah. Then you're going to love talking about Polyjet. And so Polyjet is basically we're using the Cmyk process to create models. And so, for example, this is a little 3D print of me that was done on a Polyjet printer. And this was like, I did everything backwards. So I gained a bunch of weight, then did the scan instead of probably losing the weight and then doing the scan, which would have been the right way to go. And I saw that the last podcast that you hosted, the last Meet a Maker episode with Grant from 3D Musketeers, he had a 3D print. And he used a sandstone process, which is very similar in terms of the color palette, but it's a little bit different in terms of the process. And so as opposed to using a binder material, a Polyjet system is taking droplets of resin and then using a roller, like a rolling pin, to smooth everything flat and then cure it with a UV light. So the LED is going to cure all of the resin, and then you move up. So essentially what you're doing is you're making a Sunday morning comic 1 layer at a time.
Yeah.
Hundreds of layers tall. And so
that's interesting.
The question then becomes, and so to Billy's point, so why can't you do this at home? So you have to take a step back here, and like we're going to leave the patents and all the legal stuff over here for right now.
I was expecting that was part of that.
Totally unimportant.
Because that's definitely part of it, but that's like a whole separate conversation. But purely from a mechanical standpoint, the process requires a vacuum system, a pump, a calibration process, a sub-millimeter precision roller. There's a tremendous there's a tremendous amount of math involved in terms of what we call the velocity for the jetting. So when you're dropping a droplet of that resin, you're moving the print head, so you have to sort of fire it like this. You're not really like dropping it in the way that you would think of like a DLP
you have to
or an
release
SLA.
It before, kind of like if you are.
Yeah, release from fall, exactly.
Yeah.
So mechanically,
I'm hearing a lot of this.
Yeah.
Money, yeah.
Yeah, it's a lot of expensive sensors. It's a lot of expensive feedback systems, so the machine knows where it is in space. And so that style of printing, and also at the crux of it is the part that it's sort of like the elephant in the room. Resin's really not a super safe thing to work with. Generally speaking, for people who have experience with it and have used it before, as long as you're careful, it's like using bleach. Like, right, everybody has bleach in their house. The problem is it's still kind of a lesser known quantity, and there isn't that social element of you can look at a bottle of bleach and know, like, that's not something I should be playing with. Whereas resin, I guarantee you can go on YouTube right now and find a video of somebody like mixing it with their hand or something. Like, oh, like I'm adding glitter, and
or people
it's
selling resin things to be eaten out of, or that's a whole thing.
Yeah,
You're right.
so,
a lot of people don't realize that resin's actually kind of dangerous.
So there's a tremendous liability to that too. And so once it's polymerized, the resin is, it's like anything else. It's just a polymerized piece of acrylic. But the difficult part is that resin jetting process. So like, let's say you're mixing 4 colors, you have now 4 tubes of resin, 4 sets of hoses, a pump or 4 pumps that are handling it. So you've just got like all the elements are in place for a cat to walk up and swat this thing and just spray resin all over a wall. So generally speaking, that's why we typically
Faye is like, this is so true.
I'm like, yep, that's exactly what would happen. That would be my life. That would be my life.
Yeah, that makes a lot of sense.
So Polyjet is just it's a really complex. I've only been using it for a couple of years, but it's by a long shot my favorite style of 3D printing. But it's also something where I'm aware that I don't know that it ever really will come to home use for the same reason that one of the questions I get asked all the time is, what about 3D printing metal? Can you 3D print metal? And it's in that same, SJ kind of hit the nail on the head when she's talking about the complexity of the machines. It's like, yes, but like, it's not really something that you want to have at home.
Yeah.
For the same reason you don't really want to have like an angle grinder, like, right next to your bed. Like, that's not where it's happening.
Faye's like, do I though?
Do I like?
But I could have an angle
But you
grinder.
could, yeah. So
weirdly enough, an angle grinder is probably safer.
If you can afford enough argon, and
I don't know, man. They're heavy. If you drop that on your foot, like, it's a bad day. So that's kind of Polyjet is like it's a style of 3D printing that I really like. This is another kind of fun Polyjet. So this is a little 3D printed toad that I took a close up picture of an actual toad skin and then used Blender to map that to the 3D model.
Wow.
So the toad has like little bits of like actual toad skin sort of printed right on it.
Oh yeah, the coloring's amazing.
Yeah, you can make some really vibrant parts with it too. And it passed the cat test, so I put it down and my cat swatted it and ran away, so I know it's real. Like that's how you know it's like it looks good.
Yep.
Yes. Oh, that's
cat
so
says
good.
enemy. It is real.
Yeah. Exactly. So Polyjet is a really cool style of 3D printing that ties into resin, and it's something that I've been using a lot lately, especially for full color printing. The big one to me is also multi-material. So those droplets can be different materials and durometers and different colors. So you can have something that's clear with like a red squishy spot in the center. And so for example, for the pediatric ward, when they're printing those hearts, they'll make a soft white transparent heart with a rigid red growth in it, and you can actually operate on it. And I've played around with some of the medical models, and I operated on a teddy bear, and like they 3D printed it was like a gummy bear, and you would like cut it open and then pull out like a little tumor and then stitch them back up.
That's
oh my god!
Cool.
So I did like it's a perfect example of like
cool.
What is that technology good for? So yeah. So Polyjet's cool.
Polyjet's really cool. I've always like looked at it from afar and been like, damn, you could do so much with that. Like, and the mixing of flexibles and changing the like flexible, because
that's
like,
powerful.
Yeah, like you can
that's
get real
powerful.
Flexible resin and you can mix it with, and you can do that on a home machine. I have some flexible resin, but then just be able to change it as it goes and stuff and make really different.
Yeah, that's the trick.
So cool. Yeah,
having that kind of precision to have different resins on a drop by drop level. But also, nothing against the sandstone full color printing, but the resin the Polyjet printing, it looks to be of a much higher resolution, particularly in terms of the color. The color looks amazing. Yeah, the color looks amazing. It does look like a good saturation, but also it looks like a very high resolution, almost like a print you would get off of a regular inkjet printer, as opposed to the sandstone one, which tends to be a little fuzzy. Which I'm not certain if that's a limitation of the sandstone itself or of the way it deposits color, but it looks amazing. It looks amazing at the same time. Yeah. I completely understand why it's probably not going to be in our homes. That said, I have actually seen, Billy, some homebrew kind of build it yourself full color, not the resin droplets. It's a powder. The one I saw was a powder one. It was actually, funny enough, I saw it on the website you use, Andrew, because I I'd gone through to it. What's it called? I'm forgetting now. The
Or
one
what,
you sell
Hackaday?
stuff on.
Oh,
No,
Tindy.
the one that's the one. I was on there just kind of poking around,
Yep.
and that's actually where I saw it. So you can actually purchase this. You can purchase the parts and the designs to make this yourself, and it is a full color powder based 3D printer. It looks insane to set up and then to actually print. It looks like a huge mess. It looks like a massive mess because it's using a powder and an inkjet system, but the result was pretty cool. Like I will give it that. It did look cool. It just looked like a lot. So people are kind of figuring it out, but
it is. So what you're talking about is actually a sandstone printer. And actually, I saw the one you're talking about on Tindy.
Yeah.
So it's called. They typically call it. You'll see it called by a couple different things, but typically Z-Core. That was the company that came up with the product back in the day. They were bought by 3D Systems. And 3D Systems called them CJP, color jet printing. But what you're doing is you're taking that powder and then you're depositing a layer of powder. And then you're depositing kind of a light binder material, and then you're adding your color to the perimeter.
To the dye to it.
And so very similar. And so what the machine that you're talking about on Tindy, it's the same thing, but it's a miniaturized version.
Yeah, it's small.
The typical CJP printers, they're designed like any industrial process. They're not designed to make one thing at a time. They're designed to make like 1,000 things at a time. So the idea is you would fill your tray with, 100 figurines or 100 Snoop Dogs, and then you would print all those at once because that's cost effective as opposed to making one at a time. The Polyjet process is sort of similar and like it's optimized for batch printing, but you're right about the resolution because you're taking a droplet and flattening it. You're effectively making a voxel, which is a 3-dimensional pixel, as opposed to the CJP style where you're kind of connecting these infinitely smaller and smaller granules.
Do you know what the resolution is on the Polyjet?
It's 14 microns.
Nice.
So 0.014 millimeters?
Yeah.
Or 0.14 millimeters.
No, 0.014. Because 0.1 would be
you're right. I'm sorry.
Would be 100 microns. So if it's 14 microns, it's 0.014. That's the same as a really good resin printing, yeah?
Yeah, so the big difference is you're taking that droplet and sort of depositing it and then flattening it. So you've got more of a, you can imagine how thick is a drop of water. Like it really, it's one of those how close can you measure a coastline kind of situations. So you're putting down these droplets and then flattening them to create these sort of 3-dimensional little cubes that you then cure into a layer and then you go from there.
Fascinating.
I'm into it.
Yeah.
I'm enjoying envisioning it in my head because
it's a cool
visual
process.
Yeah.
So for just a quick bit of background, so the reason I know a lot about Polyjet is and this kind of ties into what I do and why I really enjoy 3D printing is so my day job is I'm an application engineer that works with industrial 3D printers. So a big portion of what I do is finding sort of a bridge between I want to do X and I have the capacity to do Y, and finding a way to connect those two. And so Polyjet typically ties in like the industrial design world. If you are a company that is, like we make hair dryers, so how can we want to 3D print a new model? Well, like industrial design's typically got like a pretty long tail to it. So you make a clay model and then a foam model, and then you've got the color printed model. So the idea behind a process like Polyjet is like, okay, how can I speed that process up? So I can go from like a 3ds Max or like a rendered simulation to a 3D model that I can then go try. And so that's that's my day job is sort of going to companies that are working on these projects and everything from, kitchen appliances to just about anything you can imagine, and figuring out, okay, so how can we make this real? And this is, we're kind of coming up on an hour here, so I'll kind of summarize, but like, I could talk, like, this is something where I could just talk about 3D printing like all day long, but
we all.
My whole 2020 experience has been, my job is typically a lot of travel. And so I typically fly out to wherever I'm going to go see somebody and then go, talk with them, do a factory tour, look at how they're doing things now. And 2019, I keep a map in my office with like little color-coded pins of like everywhere I've been. And so 2019 was like Boston, Massachusetts down to Jacksonville and like everywhere in between over the course of a year. 2020 there's like one pin. And something that I kind of saw on Twitter recently, and Billy, I hope you don't mind me mentioning this, was the thought of, well, 2020 has been kind of a rough year, but it's been a year of a lot of personal growth. And it's been like, it hasn't been a bad year for me. And that's because in 2020, I actually, yeah, and I typically travel a lot, and I actually moved in with my girlfriend in March, like right before all the lockdowns happened.
Perfect
and so
timing.
we've kind of been talking about it for a while. And I moved in, and then all of a sudden it was like, the next day it was like everything's closed, and like there's like a big quarantine or whatever. And I was like, oh, this thing might
now you
actually
can
be a
never
problem.
leave again.
Trial by fire. Let's
And
do
it's
this.
been like,
if we last
yeah,
this, we'll
and
last
it's just-
anything. Yeah.
It's like, it's been such a refreshing experience for me to like take a little bit of a step back from traveling and building stuff and going everywhere, and like having some like real like personal time to like spend at home. And so 2020 has been kind of a wild year for a lot of reasons. But I'm really grateful for all the things that I've been able to accomplish in 2020. And part of that is like this, I stopped doing YouTube for about 2 years. I kind of stopped making videos because it wasn't really fun anymore. I did it for a while, and then it was like, it just became kind of a chore. And that was the moment where I'm like, hang on. I'm doing this because I want to. Like, I'm not being forced to do this. And so I took a step back. And then around April, I was like, oh, I think I'm going to start this whole YouTube thing again. And that kind of brings us to today.
That's awesome. Yeah, there's been silver linings in the year. I totally agree, and I'm glad you've had some as well. And yeah, that's awesome. And we're all the better for it, because now we get to hear about all the cool things you're doing literally all the time. Like,
yeah. And I don't think you're the only one either who's had to slow down.
Stuff. Pardon?
I was going to say, I don't think you're the only person either who has like kind of benefited from like the forced slowdown, because obviously our society, our culture kind of pushes us to just go a little bit more and a little bit more and a little bit faster and a little bit more. And I think that a lot of people like you kind of were kind of like, oh, okay, I guess I have to slow down now because the world is just shut down. And then going, oh, well, I can kind of do some other stuff and I can kind of enjoy being at home with my lovely girlfriend and cat, and, kind of just focus on that a little bit. And I definitely think that there has been a not insignificant amount of silver linings, obviously, in addition to
the madness,
not
and terror.
Good stuff.
Yeah.
These things can exist at the same time, but it's perfectly okay to have had a good year. I think that's okay.
Yeah, absolutely. I'm right there with you.
I actually, as I say, I have a question. So we can kick off. You were talking about your work. You were talking about, say again, what is your title? What is it? Like, what is it called? What you do? Again, say, you said it, but say it again.
So my job title is application engineer. And
right.
It is like the exact summary of the thing that I do the most in life, which is solve problems. And
which
so
is super cool.
Yeah, and it's just a great way to kind of, again, just bridging gaps. So that's my entire job, is figuring out what's the right tool for the job.
So my question then, since you've kind of talked a little bit about how you have jumped around from different things, how did you train to do this job? How did you find yourself in this job with like having the right qualifications? If somebody else wanted to do this job per se, how did you end up doing it? How did you get into applications engineering?
Absolutely awesome question. And that is like, and it's perfect for anybody who's interested in like kind of anybody who's interested in getting involved in 3D printing professionally. It's a great doorway into learning a little bit more. The way that I personally kind of found myself in this job is in around 2015 or so, I moved to Richmond, Virginia, and with a few friends opened up a 3D printing store, and that was my full-time job. I left my job. I worked in R&D as a lab technician, and I decided to pursue 3D printing full-time. And so I started a company with a few friends. And what we did is we sold 3D printers, we sold engineering services, we sold filament, we were importing like Hatchbox by like the crate. and this was like 2015, so it was a little, not like, it was like post 3D printing boom, but it was possible to run into somebody who had just never heard of it before. And what I learned from that process in running a business was the part of running the business that I really enjoyed was hearing someone say, I have a drywall company, and my biggest problem is I have this little like wedge-shaped piece of plastic that holds drywall together, and it costs me $20 right now, and I want to make it for 5. And saying like, okay, cool, I think we can do that. Like that's something we can help you with. And conversely, having somebody come to me and say, hey, I want to 3D print my house key out of metal, but I want it to be less than 50 cents because that's what I pay right now. And having to explain like why that might not be quite as feasible. And so I got a lot of experience talking to people and learning about what the expectations of 3D printing are. 3D printing means a lot of things to a lot of people. And so for people who watch a lot of science fiction, they're and they've never seen one before, they envision a 3D printer as this like big chamber where stuff goes wah, and just kind of appears. And trying to explain like, okay, well, there might be some parts have different properties depending on orientation, depending on material, depending on, the operator who made it. There's all kinds of things that go into it. And so that was the part of the job that I really enjoyed. The part I didn't really enjoy quite as much was the sales, the support, the running a business part. Like that, I didn't really enjoy that as much. And so I did it for a couple of years and then sold off my share of the business to the other owners. And then a friend of mine who worked in application engineering said, hey, I think you'd really enjoy this. I work with large systems that do X, Y, and Z. And so I looked at it and I was like, yes, I would enjoy that. So, and what I would say to anybody who's interested in getting into 3D printing professionally or interested in application engineering, learn a little bit about what people are using 3D printing for. So not just what you at home use it for, but I have like a Google News alert for 3D printing. So every time, the Ford factory 3D prints part of a hubcap or something like that, like the news sort of like trickles in. Learn about what people are doing and what their expectations are. What do people think 3D printing means? How do they think it works? And it'll put you in a really good place to be able to communicate better about how 3D printing works. And it's just about expectations is like 90% of the job, and explaining how something should be expected to work, because there's very much especially where I live, I'm in Charlotte, North Carolina, which is sort of the American South, and there's a very real sort of social expectation or societal expectation that plastic is cheaper and weaker than metal. And that's just a very, like, anywhere you go, anywhere you talk to, that's just sort of the expectation. So a lot of times you'll find a factory and they're making a part out of metal and it's like a block shape. And it's like, well, why do you make it like this? Oh, well, we've always done it that way. This is how we've been doing it since the 30s. Like, oh, well, you could probably print that out of a dimensionally accurate polymer. Oh, well, plastic's, breakable, right? Well, sure, but metal is too. Like, how much, how are you using this thing?
Yeah.
And so that's a big part of my job, is trying to find where is 3D printing advantageous? Where does it make sense to use it, and where does it not make sense to use it? So 3D printing a key to your house, feasible, practical. So, and like, that's one of those things where, you want to figure out what makes the most sense. So for anybody who's interested in it, it's definitely worth. Application engineering is a lot of fun because you get to answer a lot of questions, and you get to solve a lot of problems. And that's that is the hyper narrow niche.
Sorry, I totally
go ahead.
Over you. But it sounds almost like a design process. Like, it's sort of like designing the method for creating that thing. Like, it's not really industrial design, which is more designing the product, but it's the method behind it. Am I right in thinking that? Like,
you are. And so I actually, one of the things that I do, so my job is like, I would say 60% of that is that sort of initial consulting. The other 40% is training. So I do a lot of training classes where I'll fly out somewhere and teach for a day or two. And the class is called Design for Additive Manufacturing. And it's exactly what you're describing. It's taking those sort of like Billy's poster, by the way. I'm going to take a minute and plug it here, and I hope I don't embarrass her too much. Billy made this awesome poster of Design for Additive Manufacturing rules that you will see anywhere ever. And it covers like every wacky use case of like, I want to put a thing here, and how do I make this? It is amazing. And this is, we'll show it on screen here.
I'll make a note.
it's so useful and it's so cool. And all that information is amazing. The hardest part, and Billy knows this better than anyone because I've seen her talk about it, is how do you express that to somebody. So a lot of those design rules, like if you just tell somebody, oh, you need to have a 45-degree self-supporting angle on an overhang, that just sounds like it's like taking Spanish 2 before taking Spanish 1.
100%.
Because the first question that people are going to ask is, well, what's an overhang?
Yeah.
Like, why can't I print a V shape? Like, why can't I print
what's a self-supporting angle?
100%.
Like,
what's a self-supporting angle?
Like when I write workshops, I'm the same. I explain overhangs and all that stuff way before because the poster is like intermediate, like it's like you understand
Sure, yeah.
and you're
102.
starting to build your own models kind of thing.
Yeah.
It's not like, oh, day one, here's your printer, here's your here's how to design. Yeah, because you do like it. You need to be able to understand what that poster is because it's highly
you need a primer.
Yeah, highly abbreviated.
You kind of need to know what you don't know first before you get into it. Like you have to have a good grasp on it. So typically, DFAM, just as a general catch-all, the terminology of design for additive manufacturing is, again, I just spent a lot of time talking about it because it's like, what is it useful for, and like how can you, I'm guilty of this. My very first 3D print, when I was looking at the printer settings, the very first thing I did was I was like, I need this thing to look as good as possible. So I want it to be the finest resolution, and I want it to be as strong as possible. So I'm going to make it totally solid. And so as a result, my first 3D print was like, it took 2 days. It was solid. It was like a bowling pin, and it was just it's one of these things where like it could have been done differently. And looking back on it, I'm like, I just didn't know any better. And to this day, every time I see somebody who gets a 3D printer, their first print is always like just ripping off the build plate because it was printed totally solid at like the thinnest possible layer height. And so you're just basically taking the spool and like melting it into the shape of the thing you're making.
And like any issues you have, as soon as you make the layer height smaller, they just become more and more apparent. Like if you're over extruding just a little and your layer height is 0.2, it's kind of fine. But like if it's 0.05 or something crazy, you just like exacerbate any issue that you have,
like,
so it just looks worse.
This is bad.
Yeah.
So it's funny you mentioned that. I have a video going on YouTube today, so if you're watching this right now, then the video's already out and you can go see it. And I did a review of this printer called the RoseGo, which is basically, it was designed to print at resin resolutions, so it natively supports 0.02 millimeters with PLA. And so it was designed to print like just crazy, just super, super fine layers. And I tried it out, and Billy is exactly right. If you're printing something at like a sub-fraction of a millimeter layer height, when you're looking at that part, like if a speck of dust lands on it, your eyes are just drawn in like a laser. It's all you can see. And so this part, printing something at 0.02 millimeters, it looks awesome. Like it looks like it's been. I use like a gray color for all the test prints, and it looks like it was primed and then sanded. It looks great.
Oh, wow.
The downside is anywhere where there's like a retraction or like an overhang, it's like you can't not look at it. It's just like your eyes are just drawn to it, and you're like, oh my god. So
yeah.
And again, and so for beginners, they don't, they might not. If you're just starting in 3D printing again, you're like, okay,
yeah,
it's not intuitive, no, and like. Again, going back to like the application engineering thing, one of the questions I get asked all the time is like, well, what's the biggest 3D printer that you can print? And it's like the question you have to kind of come back with is like, well, how big are the parts you print? Because like that's important, right? Like there's a certain element of, there are printers you can get, I just saw, oh my gosh, 3D.
You can print a house
stand or 3D work stand. There was totally. But a guy flipped an Ultimaker upside down and basically has the gantry, so like the thing's like 2 stories tall. I saw a picture of it in his house next to the stairwell. Eric, that's who it was. Yeah. And I'm like, and it's like, so if somebody says like, how tall can you print a part? You're like, well,
really tall.
How much time do you have?
Yeah,
like,
you're asking the wrong question. You're asking
or the printer that's over Billy's. Yeah, the one over Billy's shoulder right now. The print mill, gorgeous. It looks so cool. It looks so like thick, like and sturdy.
It is very sturdy because I half dropped it a little bit onto the table and 0.
Oh, I'll bet it's fine.
It is. It's 100% fine. Yeah.
It is thick.
It looks like you could tumble it down the street. Like it looks so.
I'm sure I could jump on it.
My first thoughts,
but I'm not going to.
When I saw somebody unboxing one and they put it on the table, my first thought was like, that thing is going nowhere.
It was like, so hard to lift out of the box, and like it was. Yes, on my own. I really should have just got a helper.
Yeah, because the center of gravity is so low. It's like you've taken a CR10 and just like folded it over on itself.
It's very...
Yeah, actually. It's made it very dense. It's very dense on one side.
Dense is a good word.
Very dense.
Yeah. So when people are just starting out, that's kind of it's definitely like, it's one of those things where the design for additive manufacturing is good, but like even before that, you have to have kind of a basic understanding of like, how does this process work? Like what fundamentally, what is a 3D printer? And like, and this is where it gets very, sort of philosophical. And it's like, well, what am I trying to accomplish? And that's where the application side comes in. What's the goal? What's the application? And so, something I told Jeremy on the Point of View podcast was, one of the things I always say is, if somebody asks you, can you 3D print something? The answer is almost always yes, but.
Yes.
So it's yes, but to everything. Like, you can do it, but maybe it would be easier to do this, or but it would be very expensive. But like, generally speaking, it's like, could you build it with a screwdriver? Again, yes, but.
Yeah.
Yeah, no,
definitely.
there's usually more than one way to accomplish a thing. Just because you can do something, like you said before, doesn't mean you should. So yeah. 1,000 times, yeah. That makes perfect sense.
All right, I know we're like a little bit over. Can I talk about Plotter real fast?
Yeah,
So I'm like, I
you're
totally
okay.
forgot to like mention the thing that I'm working
have
on.
to talk about the plotter, because my next question was sort of going to be what's upcoming in your world. So go.
Yeah, I was wondering when you were going to bring it up. I know it's
I'm
I
like,
can.
and I mentioned before,
see
like,
it,
we haven't
so-
even talked about the plotter
So-
yet. Yeah.
I know, I've got them like floating around here. It's like one of those. I've got so many projects going simultaneously. It's so hard to like focus on any one of them. I'm like building.
All of
Tommy from Oscatone just made like, this is a little 3D printed synth where like the keys are 3D printed, the speaker grill, the whole thing's 3D printed.
I just like that it says okay in giant letters.
That is so cool.
And I'm like halfway through building his newest one, where
Oh,
each
wow.
of these little grids is its own independent timer circuit. So it's like a synthesizer where each note is its own circuit. And it is for reasons that are like, it's hard to explain if you don't really play with like circuit bend instruments, or if you don't play with like synthesizers, it's like, it doesn't really look that exciting. But to people who have designed them, it's like the musical equivalent of hooking a kazoo up to a leaf blower, like in terms of like how silly it is. Because it's got instead of having, it's like having a car with a different engine for each wheel.
Yeah,
like
so
it's such a crazy idea.
Because I don't do that much, but like, I've started to try and attempt to learn to make music for my background videos for YouTube, because it's so hard using anyone else's because of all, like, you're probably aware, like the backdating and everything. Anyway, so I've got like the iPad, and I've got GarageBand, and I've got the loops, and I'm like, oh yes, we'll just change some of these. Sorry, you're like spinning. We'll just change some of these as it goes along. Like... So I totally know what you're talking about, because they sync automatically, and if they didn't do that, it would be a nightmare.
So, or like, imagine having a different iPad for each key.
Yeah,
like that's basically what this thing is. Is it's a different iPad for each key. So each of these little white spots is a trim pot to adjust the value of the note. So like, you would hit a note down here, and then that adjusts the tuning of it. And so this is like, and then this is the case, which is super cool, and it's got the little speaker in it and stuff. And I have to print the keys next, and like, it's a whole like.
That's awesome.
I thought I had time to talk about this too, but like, I'm just getting I'm all over the place.
It's awesome.
But so
talk about the plotter.
Talk about the plotter. So plotter. So
sorry, I love the plotter.
Got really big. No, it's good. Like, this is the plotter. I'm super excited about it. I have been interested in doing like software engineering for a long time, and writing code is something I've always been sort of like. I took a couple programming classes in college, but like, I don't get to do it very often. And so back in like June, I finally had some time on my hands. So I'm like, I am going to teach myself JavaScript. I'm going to sit down and like learn processing, which I really absolutely love. But it's essentially a programming language it's more syntax based, and it lets you take an image, break it down into pixels, break the pixels down into values, and then apply different parameters to it. So you can make an image grayscale by summing the RGB values of the pixel and then averaging it to a grayscale value. Things like that.
Yeah.
And so I got really big into that, and I started making a lot of SVG art, so like a lot of traced art. And from there, I was like, oh man, this is so cool, but I wish there was a way to now make this like a thing. Like, I have a 2D file, I want to print it, but I don't want to like use a printer. So I started playing around with pen plotters, and my first pen plotter was I just took a pen and like zip tied it to my printer head and then ran it, and it worked, and I was like, okay, this is cool. So I started playing around with it a little bit more, and I finally got it to a good point, and I did a bunch of design on it. So it's got like, this is the plotter back here. You can see it kind of hooked up to my ender. But essentially, you've got like a pen mounted in this little spring-mounted bracket, so it can move up and down. So it can compensate for uneven spots in the bed. So the idea is you don't have to have the pen perfectly level, because the pens, especially the needlepoint ones, like it's essentially it's like a Sharpie that's been ground down to a tiny little point. So if you push it too hard, it squishes. And so you have to be really precise in how much pressure you have on it. Like you want to push down, but you don't want to squish the nub. So I played around with the plotter for a little bit. I looked around online. I didn't really see there wasn't really like a good off-the-shelf solution for converting 2D pen plotted art to a 3D printed pen plotter art. And a big part of that is the software workflow. The software workflow for getting an SVG to a G-code file is a nightmare.
I literally started writing my own.
That's what everybody does.
Yeah.
And that's the problem, is like everybody has their own like solution, and it's like, because you have to, and it's like, in theory,
that shouldn't be the way it is.
File,
yeah.
Like SVG
and it's
and G-code
very
is
hard.
So close. Like they're like coordinates. Both of them are just like
They're
go
coordinates.
here, then draw there, then draw. Like they're so close.
Just talk to each other better.
Like talk to each other better. It's like it is literally. I'm just like, just communicate.
Go to therapy.
Like the G code is literally just a list. It is a list of plots. It's go here, go here, go here. An SVG, go here, go here, go here. And so you're looking at the two of them like, why don't you work? And there's like no real good software solution. It's just not really like every software solution. And it goes back to like the 3D printing. Yes, but every software solution is like, oh, we can make a G code, but it doesn't work with Marlin. Or we can make a G code, but the SVG is unordered. So it'll like, if you've got like a big page, it'll like make one line here, then one line here, then one line here, then one line there, and you're watching it like, ah.
Yeah.
So
you're like, this is
one of the
worst.
things I spent a lot of time on was working with Inkscape and working with, okay, so how do I take some of these plugins and make this more intuitive to users? So the plotter is like kind of a two-part thing. One part is the actual physical plotter, which is the bracket that mounts onto your printer that can shuttle up and down and holds the pen. The other part is this like 30-page documentation that I've been working on, and Faye was actually kind enough to edit. So she looked at it and gave me some tips on how to put everything together and make it a little bit cleaner and nicer.
That's awesome.
And now it is
fantastic. Part of that document, yeah, and you did a ton of great work on it. It looks really good. I'm really proud of it. But like, the idea is I want it to be intuitive. Like I want it to be something. I want it to be something that people can like look at and like be able to go from an SVG to a G-code file themselves. And this goes back to like, why do all three of us make YouTube videos? It's because we don't have time to have that conversation with everybody. Like, I can't answer every email about how do I convert, this picture into a plottable file.
That's why I made that poster.
What do I do?
That's why I made all the posters.
It's why you made the poster.
Yeah.
It's because, like,
same
at a certain
conversation
point,
50 times. I'm like, this needs a solution.
Yeah.
Yeah, at a certain point, like, you have to, it becomes, difficult to answer, hey, my parts aren't sticking to my bed. And it's like, well, does it look like it's not sticking? Have you tried lowering the nozzle? And then 10 minutes later, hey, I tried that, it works.
Yeah.
It's like, okay, like I need to find a way to communicate
It's not leveling,
this.
It's not. I've done it 100 times, but it's always the leveling.
So yeah, it's always leveling.
Anyway,
and it's like,
such a tangent.
Send me a picture of a piece of paper under the nozzle, and then all of a sudden it's like, okay, now it works. So working with this, the big thing for me is I want to make this as accessible as possible. And so what I'm doing is I've tried to create a user guide that walks you through the process of like your very first plot, so you can make some images in Inkscape and then export them using native plugins. And I've gone through all the process of like figuring out all the different settings for your pen speed, draw height, things like that, and kind of optimized everything, and then designed the plotter. And so right now it's the plotter V1 is on Tindy, and I designed that to work with the ANET. The ET4 is it's like the Ender 3. It's a low cost. It's like $150. It's a kit printer, but it's not as common. And so I put out a call for help on Twitter. I was like, hey, I want to design this thing for the Ender. Can anybody help me with the mounting bracket for the Ender? And Pooch over at Repcord actually sent me this Ender printer to test out. And so I'm using this to test out the plotter, and it's all working now. So I'm about to actually later today, I'm going to fold this up and send it back to him with the plotter attached. So the Ender V2 should be going by the time you're watching this video. People at home or in the car or listening to this podcast. By the time you're listening to this, it should be available on Tindy, and it works with the Ender 3 and the CR10.
Nice.
And it's completely reversible. It's like a 5-minute installation. You just unscrew the hot end and put it aside, and then screw the bracket in. And all the settings for Inkscape are laid out in a document that takes you maybe 5 minutes to go through and type everything in and download. And from there, you can go through and make your own G-code art. And I've used it for making, like, I have made gifts for like everybody. It was like my Christmas cards this year were all written out using the plotter. This is Erica. And
that looks so
it's
nice
made
too.
with like it's made with 3,000 letter E's.
Oh,
so
it's
ASCII
E's.
art.
That's so cool.
So it's little E's all the way down.
Oh god, yeah.
And
super
so
tiny
like
E's.
and so I keep this. Yeah, and so like stuff like it's great for things like that, for kind of like creative personal gifts, and so writing the program that made that is something that I got. That's like the processing, that's the software side that I really enjoyed. But like again, okay, so now I've made this. How do I share this in a way where people can use it? Because it's very discouraging to make a project and then find out that there's like one part of the process that prevented people from using it or from adopting it.
Yes.
And so
you and I have talked about this a lot.
Yeah, and
it's
like part of it.
Video was a bit like that because it was just way too involved. Like, and yeah,
and it's sort of it's one of those things where like until you find that bridge to make it possible, it's a little bit harder to pull off. And so I'm really proud of the way that the plotter has come out. Like it's a really cool thing, and I'm hoping to see a bunch of them.
Fantastic.
Because just like Faye said, everybody has their own sort of like solution for getting from SVG to G-code, software and hardware. So like there's no I've never seen two 3D printing plotters that looked alike. Like everybody's got their own sort of zip-tied pen solution. And so I was like, okay, if I can make a platform that works and it's modular, it can be used on pretty much any machine. So I designed the bracket, and now using CAD files for the extruder mounting brackets on like pretty much any printer, I can just modify it and then have it work for those.
I'm so excited. I am definitely like, that document sounds like gold. I'm so
it's such a brilliant idea too.
I've been wanting to use fabric pens for ages, and I saw Jordan Mad Monkey has been doing it like this week, and I'm like, oh my god, it's like reinvigorated because I have the fabric pens. You know, I strapped a pen to my CR10S5 before, and I was like, I just need to do it now, and it's got me all excited again. So yes, I'm so getting your document. I'm so getting your plotter attachment. It's happening. I'm gonna fabric print some things.
It's like and this is like that's the perfect example. I did all this work. I took all these pictures, did all this stuff, and then he posted the picture and Jordan actually posted a picture on Twitter like I guess yesterday, yeah, and he commented on one of the things I wrote where he had like a yellow paint pen on fabric, and I'm like, I guess you could do this on fabric too. Like it hadn't occurred to me, and it's that. So that, going back to the very beginning of this podcast, like the thing that I love the most is making something, pushing it out, and then I want to see somebody posting a picture of like, hey, I used this to make my high school volleyball team's shirts this year or something, where it's like I could have had no way to predict this was going to happen.
It really is the best thing.
That is
that bit there is like that is the moment. That is the moment. It is the best bit. I agree. I feel the same. It is the
awesome. So I feel like
yes.
we came full circle here.
Yes, look at that. So round and nice.
Absolutely.
Is there anything else you wanted to chat? Oh, sorry, you go, Faye.
No, I think you're saying what I was about to say.
Oh, okay. Is there anything else you want to chat about before we round up and ask your socials and all that?
No, this has been I kind of came in with like a bit of a blank slate. I was like, I'm just going to talk about whatever feels natural, and so
comes to mind.
I felt like I've done that. I'm really excited. The ASCII tone is definitely something. The little 3D printed synthesizer. I love building circuits and I love making music, and so the idea of like 3D printing a synthesizer and an enclosure for it is like just absolutely magical to me because it's like all my favorite things tied together. And there's a few people on Twitter I know who like really appreciate like why that's so cool. So I think I'll be posting. By the time you're watching this video, you're gonna be like, Andrew, stop posting about that little keyboard. And it's gonna be that's all I'm gonna talk about for like a week.
That's okay.
But yeah, I'm really excited about the ASCII tone, and then I'm really excited about Plotter. It's just something where I'm so excited to have a thing. Again, 2020 has been kind of a train wreck in 101 ways, but in a very real way, it's allowed me to sit down and really focus on making something, start to finish, in a way that I usually don't get. And I'm usually somebody who posts a half-finished product or project online, and I'm just like, all right, somebody else carry this over the finish line. Like I can't do it.
Take it over.
So this is kind of a nice change where it's like I have time to do the photography, I get all the lighting and everything, and write the documentation.
Yeah.
Yeah, and like just totally put a bow on it, and so that's the thing I'm the most excited about.
Ah, that's awesome.
And so nice.
That's awesome.
It's very good. where can people find you? Because you are clearly a very awesome person. You are somebody to follow and watch. Where can people find you?
Pretty much exclusively Twitter at this point. I made back in March, I was like, I'll make a 3D printing Instagram, but I forgot how much I hated Instagram. Like, it's just it's like Instagram and Facebook are just such a grind to me. I have like zero desire to. Every time I post there, I make a post and I get like 100 notifications from Instagram about like people you may know. I'm like, I don't want to do this. This feels like work. It's a mood, man. And it's like, it goes back to YouTube. I stopped making YouTube videos because it wasn't fun. So I stopped using most social media. I love Twitter because it's like an instant connection to a lot of the people that I'm on.
It's more conversational.
It's more conversational, and it's more indexed. So, you know, like I follow the hashtag plotter Twitter. And I highly recommend everybody else does too, because there is so much cool stuff that happens there.
Yes.
And, you know, it's one of those, Twitter's a really great community. I know both of you through Twitter, and both of you post amazing things, and we are 3 of thousands. Like, there's, you know, for every conversation like this happening, there's somebody else like, you know, I'm 3D printing a lawnmower, and then there's like 6 lawnmower aficionados who are weighing in with their ideas, you know, and like
I do love that.
You're so connected on Twitter. Like, I helped moderate Reddit for years before I jumped on Twitter, and Discord for years. And Discord is a lot closer than Reddit. Like, Reddit, you basically never meet anybody. Even as a moderator, and I was super active, there's only a few people I made proper personal connections with. Discord, a few more. But Twitter, I feel like getting on Twitter this year was like the best thing I did, because I just met so many awesome people and became proper friends with them. Like, it's so cool. Yeah, Twitter is like this magic. Make a Twitter is the best. Like, it's so great. Yeah.
I'm here for it.
Twitter, yeah. So where can people find me? Twitter, pretty much all day long. That is like the social media account that I use the most, and it's the one that I enjoy using, and it's where I get the most like value for my social media time. Like, I see stuff that I want to see, and I share stuff that I want to share.
But you're also on YouTube.
Yes.
I'm also on YouTube. Oh my gosh, probably should mention that, right? So I'm also on YouTube. I actually just passed 12,000 subscribers, which was like a really big thing for me.
Congratulations!
I was really excited about that.
Awesome.
And I've been doing YouTube. I think I've got over 100 videos at this point, and I'm really, my YouTube videos, like, I'm most proud of the fact that there's a really wide range of like everything from like the brain scan to more recently I made chocolate molds with resin and like 3D printed parts, and then I made a 3D printed chocolate version of my face that I ate. So like
that's awesome.
Like that's
yeah.
Like I love YouTube because I feel very bad for my subscribers because they have no idea what's gonna like come down the pipe next, and neither do I. Like, I don't really have a consistent like.
I feel like
it's not like a Blender channel where I'm like
in this community. We're all random.
I do feel I do feel better about that because other makers are also sort of equivalently like, you know,
yes, please be random.
A car today.
It makes me feel better.
Yeah.
About my own randomness.
So
Thank you.
So you can find me on YouTube, and there'll be a link somewhere in the description, maybe,
we'll put them all
or somewhere
in the description. They will all be below
down there,
and we'll get your Tindy in there too. Yeah,
and my Tindy for the plotter, and of course, like, you know, if you want to learn about the plotter, or like you want to learn about like brain scans, or if you have an MRI coming up and like you're nervous about it, shoot me a message, and I can, you know, tell you a little bit about my experience and you know how you can print parts, things like that. It's to this day one of the most gratifying. I get like random messages from people who have made stuff, and the ones that always mean the most to me are people who have medical scans who are printing them out. And I get it like one brain scan a month, and it's like every time I read it, I'm like, awesome. So
that's
so
yeah. And in general, like, I'm my personal, I'm not really a big like New Year's resolution goal person, but I am trying to make it a point for 2021 to collaborate more. So I'm very open to making, if you have a project you're working on and you're like, I want to see what this would look like if it was printed on, I don't know, whatever it is I'm working on. Like, I want to do that. And so if you're watching this and you want to collaborate, shoot me a message.
Oh,
I'm
you heard him.
taking
You heard
full
the man.
advantage of this collaboration goal. We should definitely do something because I love all your stuff.
Oh, definitely.
Hell yeah.
I would love to see a plotter on the. Somebody actually asked about the print mill, and I was thinking about. I don't know if anybody's watched Arrested Development. The what? The what now?
You could make banners that way.
Yeah.
Like
That's exactly.
I was thinking really long scroll documents. Like
That too?
really
Oh
Oh my
long
god, that's so much
as a
cooler.
scroll.
That's so much better. I was thinking about like Arrested Development, like the Family Proud Michael, like the like the banners they have and all this the shows.
Yes.
Like I was thinking you could like print a banner, but like a scroll document is so much cooler. So again, yeah, like
Belt
2021,
Yeah.
let's make some weird stuff.
Let's make some weird stuff. Like, isn't that in an Avengers film? It's like, I'm gonna make so much weird stuff. Isn't that? No, it's
No,
not
I'm so-
really a quote.
I've seen like one Marvel movie and I feel terrible because I never know anything about them.
I'm like
I still
that with
haven't seen
Star Wars.
Endgame.
I'm like, yeah.
Don't feel bad. Don't feel bad.
Don't feel bad.
My girlfriend's a huge Star Wars fan. I'm Star Trek all the way. I haven't even seen. I don't think I've seen all the new ones. Like I'm still way behind. I know nothing about it. I've never seen the original 3. I've only seen like snippets. It's so cool. I love it.
That is so cool.
It's awesome.
That's awesome. That's so cool.
just
It's like the old
just
school
chilling.
communicator.
Yeah. Oh, it just woke up.
Well, thank you
'Cause it makes
so much for coming on. This has been wonderful.
Thank you,
I'm
Andrew.
so happy that we got to do this because, huge fan of your work, and this was just so great. I feel so happy now. This has been an awesome conversation, learning about so many
I've learned
things.
so
Feeling
much.
is totally mutual. I respect both of you so much for all the work that you've done, and community building is like that's the hardest part. That is absolutely the thing that I think it's like highly lacking, especially in something as decentralized as 3D printing, where there's no real there's very few centralized hubs of knowledge, and so it tends a lot of things are very community driven. But what drives the community is the community organizer, and like that's a tough role to be in. Billy, I know like being involved with Reddit and stuff, like it's hard to drive that sort of engagement and to drive that sort of positive growth. And both of you, especially with this podcast, man, it's so cool because like you just never know who's coming up next.
Yeah.
You're both doing an awesome job with it, so I
thank
admire
you.
both of your work a tremendous amount, and I'm looking forward to seeing what you guys are working on next too.
Awesome. Thank you. Well, do you want to do a tease? Do you have anything, Faye? Do you want to tease anything? We could do that. We could break the mold.
Ooh.
I'm like, what do I have to tease?
Yeah, no, I'm not.
Follow us
was
on
not,
Twitter
was not
to
prepared.
find out what we're doing.
Yeah, exactly.
I'm like, I was
not
like
prepared.
asking Faye because I'm
I was
like,
very
give me a moment, what am I
Andrew-minded.
doing? Yeah, no.
Yeah, exactly. It's very like
Follow
focused
us
on what
socials
Andrew is doing.
down
so.
there. We'll do that.
Definitely, yeah.
Well, yes. Thank you. And we will see you on the internet. We'll see you on Twitter.
See you on the internet.
Bye.
Bye.
I am loving making this series, and if you are too, please support me on Patreon so I can keep making more. Top supporters will appear in this list of legends, and the topmost supporter gets a special shout out, so thank you, Loyal Moses. You are absolutely wonderful. I know you don't only support me, but so many others in the community, and you're awesome for it. Thank you. You can meet another maker here, and here's a video YouTube thinks you'll like. If you want to catch up with any of us, all our socials are in the description below. See you later!